Welcome back to Java Internals Crashcasts. I'm your host, Sheila, and I'm here with our resident Java expert, Victor. Today we're starting a new season called Synchronization Utilities, and we'll be diving into our first chapter, Locks and Conditions. To kick things off, we're exploring the lock interface. But before we get started, let's test our listeners with a quick quiz question. In a multi-threaded application, why might you choose to use the lock interface instead of the synchronized keyword? Think about that, and we'll reveal the answer at the end of the episode. Victor, what are your thoughts on this question?
That's an excellent question, Sheila. It really gets to the heart of why the lock interface was introduced in the first place. Without giving away the answer, I think listeners should consider the flexibility and control they might need in their concurrent applications. The synchronized keyword has served us well for a long time, but as applications become more complex, developers often need more fine-grained control over synchronization.
Great point, Victor. Now, before we dive into the lock interface, could you quickly remind our listeners about the concept of synchronization in Java? It's been a while since we covered it in our previous season.
Certainly, Sheila. Synchronization in Java is a mechanism that controls access to shared resources in a multi-threaded environment. It prevents data races, situations where multiple threads access shared data simultaneously, potentially causing inconsistencies, and ensures thread safety. The most basic form of synchronization in Java is the synchronized keyword, which we covered in our previous season. It's a built-in language feature that creates a mutual exclusion zone, allowing only one thread to execute a synchronized block or method at a time.
Thank you for that refresher, Victor. Now, let's talk about the lock interface. What exactly is it, and how does it relate to synchronization?
The lock interface is part of the java.util.concurrent.locks package, introduced in Java 5. It provides a more flexible and feature-rich alternative to the synchronized keyword. Essentially, a lock is an object that controls access to a shared resource by multiple threads. Unlike synchronized, which is structured as a language feature, lock is implemented as an interface, allowing for different implementations with varying behaviors.
That's interesting. So it's like we're moving from a built-in feature to a more object-oriented approach. Could you give us an analogy to help visualize this concept?
Absolutely. Think of the lock interface as a sophisticated keycard system for a secure building, while the synchronized keyword is more like a simple mechanical lock. With a mechanical lock, you either have the key or you don't, it's all or nothing. But with a keycard system, you have more options. You can grant temporary access, revoke access remotely, or even set up different levels of access for different areas of the building. Similarly, the lock interface gives you more control and flexibility in managing concurrent access to your code.
That's a great analogy, Victor. Now, could you tell us about some of the main methods provided by the lock interface?
Certainly, the lock interface provides several key methods. The most basic are lock and unlock. As you might guess, lock acquires the lock, and unlock releases it. But there's also tryLock, which attempts to acquire the lock but doesn't block if the lock isn't available. Instead, it immediately returns a Boolean indicating whether it was successful.
That sounds useful. But I'm wondering, what happens if a thread forgets to call unlock? Isn't that a risk?
That's a great question, Sheila. You've touched on one of the key differences between lock and synchronized. With synchronized, the lock is automatically released when you exit the synchronized block or method. With lock, you're responsible for calling unlock yourself, typically in a finally block to ensure it's always called. This manual locking and unlocking is both a strength and a potential pitfall of using lock.
I see. So we get more control, but with that comes more responsibility. Are there any other advanced features of the lock interface that set it apart from synchronized?
Absolutely. Two important features are fairness and interruptibility. Some lock implementations allow you to specify a fairness policy. When fairness is enabled, locks favor granting access to the longest waiting thread. This can prevent thread starvation but may impact performance. As for interruptibility, methods like lock interruptibly allow a thread to abort its attempt to acquire a lock if it's interrupted by another thread. This is particularly useful for breaking out of deadlock situations.
Wow, that's quite advanced. I can see why the lock interface provides more flexibility. But with all these options, are there any common pitfalls or best practices developers should be aware of?
Great question. One common pitfall is forgetting to release the lock, as we mentioned earlier. Always use a try finally block to ensure the lock is released. Another best practice is to keep the critical section, the code between lock and unlock, as short as possible to improve concurrency. Also, be careful with nested locks to avoid deadlocks. As for best practices, consider using the ReentrantLock class, which is the most commonly used implementation of the lock interface. It provides all the features we've discussed and more.
Thank you, Victor. That's a lot of valuable information. Now, before we wrap up, let's get back to our quiz question. Why might you choose to use the lock interface instead of the synchronized keyword in a multi-threaded application?
Well, based on what we've discussed, there are several reasons. The lock interface provides more flexibility and control over locking behavior. It allows for features like timed lock attempts, interruptible lock acquisition, non-block structured locking, multiple condition variables, and the ability to implement fairness policies. These capabilities make it a powerful tool for managing concurrency in complex scenarios where the simple, rigid structure of synchronized is not sufficient.
Excellent summary, Victor. To recap, we've learned that the lock interface is a powerful alternative to the synchronized keyword, offering more flexibility and control in concurrent programming. It provides methods like lock, unlock, and tryLock, and advanced features like fairness and interruptibility. However, it also requires more careful management, particularly in ensuring that locks are always released. In our next episode, we'll be diving into the ReentrantLock class, which is the most common implementation of the lock interface. Don't forget to subscribe to Java Internals Crashcasts and leave us a rating if you're enjoying the series. Until next time, keep coding and stay curious.